Thanks to the lightning evolution of technology during World War II, the second half of the 20th century saw a revolution in air transport. Speed ruled the world of aeronautics, and manufacturers sought to defy time by transporting passengers faster than sound. Enter the record-breaking Concorde, a milestone in aviation history.
To many people, it probably was unrealistic to expect that you could achieve this.
The visionaries would not be deterred. The dream of building a supersonic aircraft became the symbol of the heights that technology and aerodynamics could reach, and they were determined to achieve it. Their success would revolutionize modern aviation.
Just about everything on Concorde was completely revolutionary.
How to transport 100 passengers faster than 2,000 kilometers per hour at an altitude of 18,000 meters. How to adapt fighter jet technology to a luxury commercial flight.
The fact that it traveled faster than a bullet lent a spaceship bent to the Concorde.
With its neo-Gothic wings, 4 afterburner turbojets, aerodynamic heat-resistant alloy, and futuristic cabin design, this sexy aircraft could fly from Paris to New York in just 3.5 hours at more than Mach 2, or twice the speed of sound, a record still unmatched by any airliner.
What you saw and what you experienced was just like nothing on Earth. Concorde is timeless. It was a time machine.
But it was also known for excess. Built during the 1970s oil crisis, it carried 90 tons of kerosene and burned 450 liters of it per minute during its chainsaw-loud takeoff. Its double supersonic boom barred it from flying over populated areas, and it was the most expensive civilian aircraft ever made.
Some of those airlines started to cancel, and it was like a game of toppling dominoes.
Only 14 aircraft sold. It was a resounding commercial failure, perhaps one of the greatest in the economic history of France and the United Kingdom.
The Concorde required 5 times more maintenance than conventional aircraft. And then, at the dawn of the new millennium, it suffered one of the most tragic accidents in modern aviation history, a dramatic event that hastened its end. The Concorde's unprecedented, audacious journey had a profound impact on modern aircraft design. It helped raise Europe to the forefront of technology, thanks to the collaboration of French and British manufacturers, researchers, visionaries, pilots, and technicians who created this legendary airplane that mastered the sky.
Another historic highlight in the aerospace age.
In October 1947, the Americans were preparing to launch a prototype, the Bell X-1, which was part of an experimental military program.
The Bell X-1 was the first aircraft to officially go supersonic in level flight.
It was like a bullet with 2 straight wings. It had to be released into the air by a bomber plane because it couldn't take off on its own.
It was rocket powered, and that was the only way that they could get the magic supersonic number.
Mach 1, 1,234 kilometers per hour, or 340 meters per second, the speed at which sound travels through the air.
So there was a real race on to get airplanes that would fly faster and still be controllable and usable.
In the post-war years, the Bell X-1 marked the beginning of a new competition, the race to be the first country to develop a reliable, long-distance military aircraft capable of traveling a reasonable distance at supersonic speeds.
These aircraft were designed to take off and to climb to altitude very quickly, just to catch a target and attempt to shoot it down. So we're talking about literally minutes, only minutes at supersonic speed. But we're still not talking about truly a sustained supersonic flight for very extended periods of time.
This unprecedented technological advance pushed the superpowers to undertake a seemingly crazy project that would revolutionize air transport and allow them to dominate the skies, the creation of a supersonic commercial aircraft.
In the 50s, a lot of people saw that the next generation of commercial aircraft would be supersonic, and supersonic would be the thing of the future.
All without G-suits, helmets, oxygen masks, or ejection seats. Seemed totally unrealistic.
Putting 100 people inside a bullet was an unthinkable dream.
But this dream was to become a reality. The Americans developed the Boeing 2707 and the Lockheed L-2000. The Soviets worked on the Tupolev Tu-144 project in secret. The race was on, and no one expected the Europeans to cross the finish line first. But in the end, it was the Franco-British alliance that brought it home.
This project was a major challenge for Europe, which wanted to reposition itself as an aeronautical power with respect to the United States.
The British aeronautical industry came out of World War II having made stupendous advances.
But in France in 1945, the level was very low. They were behind in every aspect.
At the end of the 1950s, the French and the British began to develop their own supersonic aircraft projects. The Super Caravelle and the Bristol 223, two competing projects funded by their respective governments.
If you want to, say, cross the Atlantic or perform a long-haul flight with a supersonic jet, you're going to have to fly at supersonic speeds for several hours. So you're really upping your game in terms of technology, and people realized that this would be expensive.
So we didn't have a very hard job to convince the other industry that we should combine and work together.
The similarity of their design plans led the two governments to join forces in 1962 to collaborate on a single aircraft. It was a first in the history of aeronautics. Sud Aviation, which would eventually become Airbus, and the British Aircraft Corporation joined forces to create Concorde, an agreement between the historic rivals.
The aviation industry believed it was possible, but no one knew how to do it.
The technical specifications were ambitious. The industry wanted an aircraft capable of making a transatlantic trip at Mach 2, or nearly 2,200 kilometers per hour, with around 100 passengers on board. The technological challenge was immense because in the 1960s, the only planes capable of handling non-stop flights from London or Paris to New York did it in more than 8 hours at a cruising speed of 800 kilometers per hour.
We didn't have the propulsion. We didn't have the materials.
It was a huge technological leap.
In 1966, the construction of two prototypes began simultaneously, one on either side of the channel. The Concorde 001 in Toulouse and the 002 in Filton.
There was an ambition from the start to recognize the strengths of each country and also to end up with a balance of technical involvement and an equal share of financial involvement.
A little more of Britain's work was on the engines, and a little more of France's work was on the airframe.
France was traditionally at the forefront of aerodynamics. Propulsion was England's forte, and by combining talents, we had a better chance of succeeding.
The engineers had to undertake extensive studies to develop a new technology in record time with many unknowns. How could passengers be safely transported at Mach 2 at an altitude of more than 18,000 meters over a distance of several thousand kilometers? That was a privilege previously reserved for military planes.
With the concept of putting 100 passengers in their shirt sleeves with no special environmental protection was really pushing the boundaries of everything.
The technical aspect was complex, requiring the perfect balance of speed and range. In terms of speed, the Concorde had to be able to function at both subsonic speeds, those of a conventional aircraft, and the supersonic speed of a military aircraft. Therefore, they had to design an engine capable of operating for several hours at Mach 2 with unrivaled thrust while consuming as little fuel as possible. The wings also had to be optimized to allow for stability in two different flight regimes and to store the fuel needed for a transatlantic crossing. Finally, they had to completely redesign the cabin to cope with pressure variations never before encountered in the history of commercial flight.
And so there were all these special technologies that had to be developed and all come together at the same time.
In terms of aerodynamics, materials, and flight controls, the Concorde helped advance the rest of the industry.
This aircraft would be a pioneer in all areas, starting with the profile of the aircraft with its neo-Gothic wing. The aerodynamic profile of the Concorde was one of the keys to sustaining supersonic speeds. Its fuselage, wings, glide ratio, weight, and lines were decisive in its ability to withstand dynamic forces during flight.
There were several challenges. First was to build a wing that was perfectly suited at flying at Mach 2 for an ocean crossing that lasted more than 3 hours or more than 2.5 hours at supersonic speeds.
And secondly, the highest efficiency of the wing at low speed.
As you could take off and land at conventional airports, on conventional runways, and fit in with traffic patterns with conventional aeroplanes without causing any disruption.
A balance of 4 forces is what keeps an aircraft in the air and propels it forward: lift, weight, thrust, and drag. The airflow over and under the wings creates lift. This force directs the aircraft upwards and compensates for its weight, allowing it to rise into the sky.
All a glider, an airfoil, or an airplane needs is enough upward pitch to create excess pressure underneath, and most importantly, a depression above.
That pulls the plane up, creating a lot of lift and a little bit of drag.
Drag is the force that opposes the motion of the plane. It must be counteracted by the propulsion provided by the engine. But the amount of drag created at speeds beyond Mach 1, 1,000 kilometers per hour, could break the classic wings used on airliners. So what kind of wings should be used instead? Could a delta wing, commonly used on fighter jets, be adapted for a civilian aircraft carrying passengers?
Delta wings first appeared on military aircraft, on fighter jets during the 1950s.
Delta wings are suitable for supersonic flight. All aircraft capable of supersonic flight have wings that are steeply swept back or triangular shaped.
Delta wings are great for high speeds.
However, they're not very suitable for low-speed flight. They don't create much vertical force or lift, which is what relieves the weight of the aircraft.
If you use a simple delta wing, you are going to get a very high takeoff speed, especially if we're talking about a large commercial aircraft.
The focus was on the delta wing. It would make it possible to fly at more than 2,000 kilometers per hour, thanks to its structural strength, limited weight, and carrying capacity, which could accommodate nacelles. However, it would have to be optimized to improve its lift during the takeoff and landing phases. A series of hand-drawn plans, sometimes drawn to scale, were used to build the first models intended for dynamic testing of the wing. It was at Onera, in the heart of the Alps, in one of the biggest wind tunnel centers in the world, that the first models of the Concorde wings were tested in real conditions.
This is the 1/75 scale model that was used in the S2 and S3 wind tunnels for testing. They'd start the wind tunnel at a certain speed, for example, 600 kilometers per hour, and then make adjustments to the angle of the model in relation to the wind, which is to say from 200 kilometers per hour up to 2,000 kilometers per hour. You have to imagine that all of this was machined to the nearest tenth of a millimeter. It's still one of the best ways to simulate what will actually happen in flight.
But they started off with basically a delta wing and said, well, let's see how far we can go with that, and let's see what changes need to be made to that to satisfy the requirements of Concorde across this huge range of speed.
After 50 test campaigns, the engineers no longer had any doubt. The delta wing would have to be revolutionized. The triangular shape took the form of a warhead. The straight lines gave way to 2 curves, creating an almost architectural form: the Gothic wing. This new design allowed the lift of the aircraft to be increased by 15 to 20%, thanks to the generation of vortexes above the wings.
The air circulated in such a way as to create rotation. That rotation created a vortex above the wing, which grew to massive proportions.
It's constantly replaced by generation of new vortices.
That would literally suck the airplane into the air.
It allows you to create additional lift and land more slowly.
It was the best possible compromise between the ability to fly at high speeds with low drag, but also the ability to take off and land and at an acceptable speed for a commercial aircraft.
The genius of the Gothic wing was that it could land like a flower and fly like an arrow.
This new wing shape provided stability in all phases of flight, both subsonic and supersonic. The fuselage, or body of the plane, needed to be as narrow as possible in order to facilitate its entry into the atmosphere. But when an aircraft is traveling at supersonic speeds, the structure also has to be able to deal with a thermal phenomenon of great intensity, aerodynamic heating.
The biggest risks are temperature and temperature cycling and the stresses that are caused by those things.
Any aircraft or any object traveling at high speed through air will heat up.
As a plane moves through the air, it compresses the air in front of it, so it compresses the air at the nose and at the front edge of the wings, which produces heat. The Concorde flew at about 2,000 kilometers per hour.
The amount of heat produced was considerable. At Mach 2, the temperature on the structure reached 120 degrees Celsius.
From Mach 1 to Mach 2, the temperature is multiplied by 8. Therefore, the fuselage and wings had to be made of something that could withstand this heat for several hours.
The Concorde made history because the famous Au2GN, the Concorde alloy, was invented to deal with the temperatures, but it was still an aluminum alloy.
It was the choice of the material to build Concorde that determined how fast it could go.
In its final version, the Concorde was 62 meters long, and because of that length, the heat caused the fuselage to expand in mid-flight.
Because of the heat, the Concorde was 25 centimeters longer in flight than on the ground.
So this is tremendous kinetic heating. The aeroplane has grown so much that you could put your hand between the flight engineer's panel and the bulkhead behind it.
When it was at its cruising speed of Mach 2, it lengthened by 25 centimeters. When it landed, it returned to the normal temperature and its normal length.
This Gothic wing, so characteristic of the Concorde, was the optimal wing for its lift. The next challenge was propulsion. What kind of engine would be able to propel these 180 tons into the air?
So one of the requirements would be more thrust for takeoff. That is 380 kilometers per hour. And so you have to reach the speed before you reach the end of the runway.
It's impossible to go from 0 to 2,200 kilometers per hour instantly.
During the pre-design phase, several propulsion options were suggested, including a nuclear propulsion system calling for an armored trunk containing an atomic battery to be placed inside the plane near the engines. This type of propulsion would provide an almost unlimited source of energy while maintaining a constant mass, and therefore fly much longer distances than expected.
Carrying plutonium in a civilian aircraft would be extremely dangerous. Obviously, the challenge is radiation, and it would have been necessary to put the nuclear reactor inside a very heavy armored chest. Weight is the enemy where aircraft are concerned, so this type of propulsion was quickly ruled out.
The expectations in terms of propulsion were extraordinary. They had to find the most powerful engines available in Europe, and only the British had the technological capacity to develop such propulsion.
Britain had a cutting-edge engine manufacturer, Rolls-Royce.
The British already had a core engine that could at least be the starting point for that engine in the Olympus, which was already in service as the engine for the Avro Vulcan bomber.
Even so, it had to be increased in size and in power and in efficiency and capability in order to power an aircraft such as Concorde.
A 4-engine jet system designed by Rolls-Royce and Snecma was selected. It had titanium and steel nacelles that could withstand very high temperatures and 4 Olympus 593 turbojets, 2 under each wing. These 4 turbojets would propel the 180 tons of aircraft at 397 kilometers per hour during takeoff and provide a power needed to reach a cruising speed of Mach 2.04, or 2,179 kilometers per hour at an altitude of more than 15,000 meters.
The Olympus 593 engine ended up at 32,000 pounds of dry thrust.
The thrust provided by these four engines resulted from the acceleration of the air between the inlet and the outlet of the engines. It was obtained by burning kerosene in the oxygen contained in the air passing through them. The energy produced was recovered by a turbine that compressed the air at the reactor inlet, thus creating thrust at the outlet. But the transition from subsonic to supersonic speeds required the existing Olympus engines to be modified to optimize their performance. The reactors had to be adapted by the addition of two essential parts: air intakes and nozzles, each of which had their own controls and made it possible to adjust the airspeed in and out of the engine.
The Olympus 593 engine is a subsonic engine operating in a supersonic environment. And that means that you cannot put air through that engine which enters the engine at supersonic speed.
Two-dimensional variable geometry air inlets were installed at the front of the engines. These huge movable panels measured and regulated the flow of air entering the engine using flaps.
The shape of the air inlets had to be adapted depending on the speed of the aircraft.
This slowed the flow from Mach 2 to Mach 0.55 at the engine inlet. The second challenge was to manage the exhaust.
The engineers installed nozzles at the engine outlets. These sections, composed of high-temperature steel tubes 1 meter across, were used to accelerate the air leaving the reactor, allowing the Concorde to exert maximum thrust.
Supersonic expansion caused the speed to increase even more as the fluid exerted outward pressure. That fluid, because of subsonic and then transonic flow, became supersonic or even hypersonic. This technology was already being used in fighter jets, so civil aviation benefited from Formula One airplanes, which is what fighter jets are.
But the Concorde had to deal with a delicate transitional flight situation. The transonic regime, a boundary where drag increases and lift decreases, and the balance of forces that keeps the aircraft in the air can be disrupted.
The transonic phase of flight is when an airplane is accelerating from subsonic speed, so less than Mach 1, through to speeds greater than the speed of sound.
Breaking the supersonic barrier is difficult.
When you go through the wall, there are resonances.
The plane doesn't want to move forward. The shockwaves are all over the place.
The plane is temporarily almost uncontrollable.
How did they find the power needed to get through this phase of flight that required extreme thrust? The solution? Afterburners. The four engines of the plane were boosted by reheaters. In this crucial step, a pump and a high-pressure fuel regulator sent additional fuel to the Concorde's engines.
Kerosene was added to the combustion chamber to make a rocket.
20% or so thrust without heavily modifying the design of the engine.
When you added the afterburner at takeoff, it acted as an extra engine, and you could feel it because the impact of the thrust was pretty much instantaneous. It felt like you were getting kicked in the butt.
When they turned the afterburners on, it was like having a rocket engine at the outlet.
As a pilot, the excitement, the exhilaration you got on takeoff was phenomenal.
The afterburners provided an incomparable additional thrust, but at what cost? Consumption during this acceleration skyrocketed. 80 tons of kerosene were burned per hour, more than 1 ton per minute, 4 times more than at cruising speed.
Between the moment the engine turned on and the moment the Concorde took off, it burned 1.5 tons of kerosene.
It was a monster in the air. Despite its narrow body, the plane had to carry 95 tons of kerosene to be able to travel the 6,580 kilometers of a transatlantic flight.
To cross the Atlantic, that's nearly a ton of fuel per passenger on board.
The Concorde consumed 4 times more passenger than a subsonic aircraft. By the end of a crossing, if everything had gone well, we arrived with about 20 minutes of fuel to spare. So it was very restrictive and put a lot of pressure on the crews operating the flight.
The pressure at the controls was real, and they had to deal with a heavy load as well. When it reached Mach 1, the aircraft's aerodynamic balance changed. Its center of lift moved further back. The challenge was to adjust the balance of the aircraft to avoid stalling in mid-flight.
They had to move the center of mass of the aircraft in mid-flight while breaking the sound barrier. They could have asked all the passengers to move to the seats at the back of the plane. Instead of doing that, they decided to move the fuel.
The Concorde had 13 fuel tanks that were distributed in the wings and the fuselage, which allowed for the longitudinal balancing of the aircraft.
This balancing was carried out by the flight engineer in the cockpit, with their eyes riveted on the levels of the 13 tanks and the flight speed. They transferred fuel from front to rear for supersonic flight and vice versa when the Concorde returned to subsonic speed. By doing this, they stabilized the center of gravity in any condition. The entry into the supersonic world didn't only have consequences on the structure of the Concorde, it also disturbed the environment of the aircraft.
There was a point where the air could no longer keep up with us, and we exceeded that perturbation velocity.
As it approached Mach 1, 1,234 kilometers per hour, or 343 meters per second, the Concorde crossed the equivalent of more than 3 soccer fields in just 1 second. The Concorde then began to catch up with its own wake in the air. As the speed increased, the shock waves combined to form a single large wave, which became a veritable barrier of compressed air at the front of the aircraft.
When you reach the speed of sound, you just go as fast as those waves. And when you surpass it, these waves add up, and they create drag.
So the shock wave that the aircraft produces, this travels to the ground, even if the aircraft is at cruising altitude.
At some point, the shock wave reaches the ground. When it goes through you and it hits you, you feel a difference in pressure in the ears, and it's perceived by the ears as a loud bang.
You hear all the noises at the same time, and it's like a big bang. And you drag this cone, this wave, along with you as long as you're in supersonic mode.
The wave isn't only under the plane, it's tens of kilometers wide.
This supersonic boom is heard by everyone on the ground. The Concorde actually generated 2 shock waves on its structure, one on its nose and one on the back of its wings, causing a double detonation. Combined with the noise of the 4 Olympus engines, the aircraft produced exceptional noise pollution close to the pain threshold.
Inside the plane itself, you didn't feel anything at all because the pilots and passengers were all inside that cone. The only evidence the pilot had of the switch to supersonic speed was when we passed Mach 1, when one of the shock waves receded onto the surface of the plane and passed in front of our sensors, and the aerodynamic instruments would go a little crazy. We'd always see we were passing Mach. It was only when we looked at the dashboard that we realized how fast we were going. We were traveling at 20 nautical miles or 36 kilometers per minute, and we saw the indicators moving.
Speed, engine rotation, consumption, pressure, temperature. In the cockpit, the numbers were enough to make you shudder. Because of the lengthening of the fuselage at supersonic speed, engineers had to install all-electric and analog flight controls for the first time on a civilian aircraft to avoid cable transmission. This cutting-edge technology was picked up by Boeing 20 years later.
The manufacturer integrated expandable fittings. This means that the pipes were able to slide relative to one another depending on the expansion of the materials around them.
The slender shape of the fuselage, coupled with the high angle of incidence, caused very poor forward visibility for the pilots. While this wasn't a problem while cruising, the situation was more critical when landing.
We were pitched up at 10 degrees, plus the nose, which is several meters in front, and we could barely see the runway at all.
You have to realize that the pilots were more than 12 meters above the ground when the plane touched down.
To overcome this situation, a 7.3-meter-long tilting nose was installed at the front of the aircraft, which could be inclined by up to 12 degrees when landing. Those weren't the only safety measures taken. For the first time in the history of civil aviation, the medical profession worked with engineers to ensure the safety of passengers traveling at more than 2,000 kilometers at an altitude of 18,000 meters. At such a high elevation, sudden depressurization would result in a loss of consciousness in about 10 seconds.
It was going to be subjected to much higher internal pressures. The actual pressure inside the cabin was twice as much as it is inside a conventional subsonic airliner.
The engineers had to design the cabin structure with flawless compression circuits, install high-pressure oxygen masks, and equip the aircraft with small windows in order to minimize depressurization in the event of accidental rupture.
Nobody was actually sure that everything was going to work and it would be perfectly safe for people to be sitting as if they were in a normal airliner, traveling at twice the speed of sound.
The Concorde moved extremely fast, but it also had to be able to brake. Each wheel was equipped with 8 ventilated carbon brake discs, an advanced anti-slip system that reduced stopping distances by 15% in dry conditions and improved safety in wet conditions. This system would later be used by Airbus on the Mirage F1 aircraft.
Everything was a challenge. The weight, the structure, and issues related to aerodynamics and air conditioning. It was a challenge on every level.
Every component, every technology used was either innovative or completely revolutionary.
The French and British defied time and revolutionized aeronautics by designing one of the most iconic airliners. A year and a half after assembly began, the first French prototype, Concorde 001, was officially presented in Toulouse on December 11, 1967. But an unexpected event from the East stunned the Concorde's engineers.
Everyone knew about the different projects underway. It was well known that the Soviets were also working on their own supersonic civilian aircraft.
But it was the Cold War, so it was very difficult to know what was happening in the USSR at the time.
In December 1968, just 3 months before the first test flight of the Concorde, the Soviets conducted the first flight of their supersonic aircraft, the Tupolev Tu-144, a project that had been kept secret until then.
The French and British were slightly dismayed by the fact that the Russians got the Tu-144 into the air.
The similarities to the Franco-British aircraft were obvious. The Concorde was said to have been the target of industrial espionage.
If they did, they never understood the subtleties of the Concorde wing design because they made a much simpler wing. The Tu-144 was very much sort of 1950s technology, dressed up to look like 1960s technology.
Despite the shock from this Soviet copy, a few months later, the eyes of the world were riveted on the Concorde as it prepared to take off from Toulouse-Blagnac Airport. 400 journalists were invited and thousands of spectators flocked to try and catch a glimpse of this exceptional aircraft for the first time.
It was a reality check.
The loss of an aircraft wasn't an option even during testing because it would have a catastrophic effect on the sale of the aircraft to the airlines. Blagnac Airport, you're go for takeoff.
Nose come up to 20 degrees, she's airborne. She flies.
The Concorde took off from the tarmac of Blagnac at more than 300 kilometers per hour. The plane climbed to an altitude of 9,000 feet or 2,700 meters. The crew tested the aircraft's steering and made adjustments to the speed and altitude, but didn't break the sound barrier. Then the plane gently touched down.
The impact of this flight was considerable, contributing to the Concorde's immediate status as a media star.
It was like seeing the Apollo rockets take off at that time. None of us thought we'd ever travel in one.
The Concorde 002, the second prototype, took off a month later from Bristol Airport in England. It was during its 102nd test flight that the Concorde reached the long-awaited speed of Mach 2, or 2,469 kilometers per hour. The engineers were right. The airplane was a technological success.
It was a big propaganda It was proof that the British and French industries were back on stream in competitive terms.
The Concordes recorded more than 5,000 test flight hours, 4 times more than conventional commercial aircraft. It was the longest test program in the history of civil aeronautics. This period also marked the beginning of all its speed and altitude records.
One of the goals during the testing process is to push the aircraft a little bit beyond its normal limits.
They reached 2,500 kilometers per hour. They knew they had to stop when they saw the windshield burning.
They took the aircraft well above 20,000 meters, which, if you think about it, is nearly twice the average cruising height of a normal airline.
It was a tremendous privilege to find yourself flying on the edge of space, where the sky above you was black. You could see the curvature of the Earth.
It was kind of philosophical for the period of the 1960s. It was like the climax, the high point. It meant that from a technical point of view, humans could do just about anything in the air.
We'd say, "Look, the Concorde is coming." And everyone would rush to see the plane, majestically arriving like someone who had just achieved a great feat. It was a work of art.
In October 1975, the Concorde finally received its airworthiness certificate. The British and French production centers could start building aircraft to meet the numerous orders that international airline companies had promised to place. Although they were optimistic at first, the manufacturers were soon to be confronted with a bitter failure.
The success of Concorde now depends on getting the orders and producing the planes to time.
They hoped to get 250 or 300 orders in fairly quickly, including from U.S. companies such as Pan Am. The famous American airline had been planning to buy Concordes before 1974.
The beginning of the 1970s was marked by a chain of events that caused the cancellation of all foreign orders. In June 1973, the Tupolev Tu-144, the Soviet supersonic aircraft, was demonstrated at the Paris Air Show in front of 350,000 people, alongside the Concorde. During the show, the Tupolev stalled, resulting in a fiery crash in front of 350,000 people and TV stations from around the world.
This crash contributed to questions about the safety of supersonic flights. That's when we started to get a sense of the operational difficulties.
The image of supersonic aircraft was tarnished before commercial flights even began. Then the issue of pollution was raised. Finally, the noise generated by the supersonic boom didn't make it any easier for the aircraft to sell.
The other major problem, and perhaps the reason that killed the market for Concordes, was sonic boom.
In the United States, anti-Concorde protesters tried to sabotage the arrival of the Franco-British plane. They claimed the bang would shatter the windows of entire cities. This activism masked the Americans' resentment of the Europeans in the face of their inability to develop their own supersonic aircraft, as their plans for the Boeing 2707 and the Lockheed L-2000 had been abandoned.
They completely banned Concorde from American airspace.
4 months after the Tupolev crash, the first major oil shock occurred. The price of kerosene increased by 70 to 100%. It destroyed any hope of profitability for the Concorde, with its consumption of 95 tons of kerosene per flight. Airlines were in financial trouble and renounced their investments. In the press, supersonic flight was described as an industrial Vietnam.
14 were sold on a compulsory basis to British Airways and Air France. Only 14 aircraft were sold. It was a resounding commercial failure, perhaps one of the greatest in the economic history of France and the United Kingdom.
A paradox for this exceptional aircraft, which had been destined to be a great commercial success. The program had to be made profitable by making the Concorde synonymous with greatness, influence, and prestige. On January 21, 1976, TV stations around the world broadcast the 2 commercial flights live, an Air France flight from Paris to Rio via Dakar, and a British Airways flight from London to Bahrain.
I was a schoolboy. I was clinging to the fence with thousands of other people watching that takeoff. If somebody bet me £1 million that one day I would fly that very airplane, I would have laughed and not taken that bet.
Recognizing the success of these early commercial flights and seeing the advantage of supersonic flights, the Americans eventually lifted their ban and authorized the first landing on New York soil on November 22, 1977.
When we landed in New York, our English friends were also arriving from London at the same time. And we found ourselves on the tarmac at JFK. Two wonders of a plane nose to nose. It was a very emotional moment at the airport.
During its first 6 years of operation, the Concorde was constantly adding more destinations on 5 continents. These routes established its legend all over the world.
When we arrived in a place where the Concorde wasn't known, we felt like it transformed everyone. People were smiling, welcoming, and friendly.
Concorde certainly drew crowds everywhere she went.
People were really excited to see it fly.
A legend was born. The flight from London or Paris to New York took just 3.5 hours. It even set a record of 2 hours and 59 minutes. It takes more than double that today. Supersonic travel solved the problem of jet lag and made it possible to arrive in New York at the start of the workday.
You could leave Paris, say, at 11 a.m. and you would arrive in New York before 9 a.m. local time.
No jet lag, no fatigue. Only the Concorde could do that.
Concorde services started before internet, before the smartphone, before video conference, before electronic signatures. So people really had to get around a little bit more for work.
The average price of a round-trip ticket to New York was 50,000 francs or $9,000 back then. Such was the price to pay to reach the east coast of the United States in just over 3 hours. Prices surpassed 8,000 euros in the early 2000s. Flying in the beautiful white bird meant traveling in one of the most prestigious aircraft of the time. The service on board was comparable to that of a luxury hotel, with a hand-picked staff dedicated to the comfort of the 100 passengers.
The dishes were prepared by chefs. The chefs worked on the meals for months because the food was delicious. But at that altitude, your senses differ enormously. The meals were served on plates made of genuine Limoges porcelain. You could eat with silver cutlery, drink from a crystal glass, and at the end, you were offered a cigar. They had a very, very good time on board.
There was a kind of complicity between the passengers and crew, a much more intimate relationship than other flights.
Stars of show business, CEOs of companies on the CAC 40 stock market, royalty, heads of state, and high-level athletes all boarded the plane to test the mythical machine and recognize the merits of its innovations.
I remember a gentleman getting off once and looking slightly disappointed, and I said, "Did you enjoy your flight, sir?" He said, "Well, it was a bit disappointing when we went through the sound barrier. I thought it'd be more spectacular." And I said, "That's the whole point, sir. That's what it's all about. That's the clever bit."
To satisfy its wealthy clientele, the Concorde was subject to draconian technical constraints in terms of safety and punctuality, requiring 18 to 20 hours of maintenance per flight hour, which is 5 to 7 times more than a conventional aircraft.
There was always one plane doing the flight and one on standby, so that meant that from a maintenance perspective, we had to prepare 2 planes every day.
Faced with such high maintenance costs, the bottom lines quickly became unprofitable. From 1983 onwards, only daily flights to New York were offered for profitability reasons. But in 2000, 24 years after its first commercial flight, a dramatic event quickly brought about the end of the myth.
The unthinkable happened. We all remember where we were that day.
On July 25, 2000, Air France Flight 4590, chartered to take German tourists to New York, was on the tarmac at Charles de Gaulle Airport. The aircraft, the 6th in the series, was ready for takeoff. It was 4:42 p.m.
It was a classic charter flight.
The aircraft was fully loaded with passengers and luggage.
The plane started its flight a little late due to a technical issue. Something happened that caused a short delay, but that was only the beginning of a sequence of events.
Less than 2 minutes after takeoff, the plane became uncontrollable. It stalled and crashed into a hotel on Highway N17. The tragedy resulted in the death of 100 German passengers, 9 crew members, and 4 people on the ground, for a total of 113 victims. The news of the crash spread within minutes, and the eyes of the world were riveted on the disaster that had occurred at 4:44 p.m. No one had ever imagined a Concorde might crash. So what happened? At an altitude of 65 meters, just as it was starting to take off, the Concorde lost all power, which meant there was no more acceleration.
Up to a speed of 170 knots, the acceleration is still quite significant, but in this case, it had practically stopped. That's when they must have started to wonder what was happening.
The drama unfolded right in front of the Roissy control tower. A huge flame appeared under the left wing of the plane. Air traffic controllers alerted the pilot, but the aircraft had already reached a speed where it was no longer possible to abort taking off or come to a stop.
There was nothing they could do but take off and try to analyze the erratic parameters once they were in flight. The indicators for the left engines were going crazy. One thing happened after another, to tragic effect. The landing gear wouldn't retract, so the plane had a thrust deficit. It was at low speed, it couldn't accelerate, and the aerodynamic center shifted abruptly to the front of the wing, causing the plane to pitch upwards.
The aircraft lost speed and altitude and banked to the left from 40 degrees to 100 degrees at a speed of 251 kilometers per hour. The instruments stopped responding. As was inevitable, the Concorde crashed into the hotel below, just 2 minutes after takeoff. One of the most tragic accidents in the history of modern aviation occurred in front of hundreds of witnesses.
We were all shaken to the core. The world was shaken to the core. Airline pilots around the world could not believe that Concorde had crashed.
The accident was unbelievable from every point of view, both in terms of what caused it and the media coverage that followed.
The investigation into the crash lasted a year and a half. The analysis revealed a chain of several factors that combined to cause the accident.
An aircraft, a DC-10, that had taken off 4 or 5 minutes before the Concorde had lost a small part of its engine. It landed in a place where the Concorde happened to roll over it. At about 170 knots, which is above the decision speed, the aircraft couldn't stop, so the crew continued on without even realizing what had happened, because they couldn't see it. They found the piece of debris and the tire later. The part fit perfectly into the indentation of the tire. It was very clear.
The piece of tire hit the lower wing of the Concorde, creating a shockwave in one of the tanks. The wave bounced off the upper part of the wing, then came back to puncture the lower part of the tank.
A massive amount of fuel leaked out. There were several tons of fuel stored in that tank. The metal parts rubbing against the runway created sparks.
The fire spread, and the pieces of tire and the landing gear were sucked into the engine, causing the compressor blades to stall and the number 2 engine to lose power, followed by engine number 1. The crash was inevitable.
There were a myriad of causes for that accident to happen. It wasn't just one thing. The aircraft was overloaded, it was taking off with a tailwind, there was the missing spacer from the undercarriage, there was the bit of metal on the runway that burst the tire, the fuel tanks were over full. All those factors came together to cause that crash.
Had the plane taken off just 5 minutes later, the accident wouldn't have happened. It was fate, the chain of events that led to the tragic accident.
Authorities on both sides of the channel grounded all Concordes. The aircraft's airworthiness certificate was suspended, a rare occurrence in the history of aviation. On the evening of July 25, 2000, the future of the Concorde remained uncertain.
An incredible team of people came together to return Concorde to service. She could not end like this.
Following the disaster, major modifications were made to the aircraft. The tanks were equipped with Kevlar protection. Stronger tires and new electric landing gear were installed. The capacity of the airplane was reduced by 10 seats. The legendary plane had to be reborn, so the necessary measures had to be taken to avoid another catastrophe. More than a year after the accident, the return of the Concorde was scheduled for 2001, just a few days before the attack that shook New York City.
That significantly undermined international confidence in travel and specifically in flying.
Despite the amount of work that had been put into the modifications, the adventure of the Concorde was on borrowed time.
The Paris crash obviously shattered everybody's confidence that Concorde was a safe aeroplane.
Load factors decreased to about 30% in 2003.
And passenger loads were such that Concorde became unviable, and the cost of maintaining the aeroplane was going through the roof.
The trigger was Airbus's decision to increase the costs of the engineering support for the aeroplane. The airlines looked at it, and Air France said, well, that's it.
It's no longer possible, economically or otherwise, to continue, so we're in the process of bringing this extraordinary journey to an end in as dignified a way as possible.
British Airways could not have carried on their own, so in a sense the Air France decision became the British Airways decision.
On April 10, 2003, the axe fell. It was the end of an era. Air France and British Airways announced the withdrawal of all Concorde aircraft scheduled for the following year.
We understood that it was over. So what were we going to do? What will we do next?
I was in a beach bar in Barbados with a rum and coke in my hand and a tear running down my cheek.
I was sad, of course, to see the flights halted. I was joined in that by numerous spectators who rushed to obtain a seat on one of the last flights.
The last flights were celebrated with dignity at each airport, where thousands of people flocked for one final tribute to the beautiful white bird.
All the flights were completely full for that last 6 months, and it was to be a celebration of what we had achieved with Concorde.
The planes were transported to museums. The end of the Concorde caused a major stir in the aviation world. Mechanics, pilots, flight attendants, and enthusiasts alike, 2003 marked a turning point in the history of aviation.
We had the Concorde, then nothing after it. Where's its replacement? There isn't one.
So this is a capacity we've lost in a sense, and I don't think people are used to this.
Despite being the subject of one of the most heated controversies, the Concorde remains one of the greatest feats of the 20th century and a success of aeronautical development, one whose technical advances have considerably marked the design of aircraft today.
It was an extremely large technological gap.
You have to understand that Airbus wouldn't be Airbus today if it hadn't been for the Concorde. People understood the rarity of the machine.
Concorde was unique. While it was flying, it was the one aeroplane in the sky that everybody recognized. It could be 10 miles away and you see the shape and you know, that is Concorde.
And even if you look at Concorde now, an aeroplane that was conceived in the 1960s, she looks futuristic. Concorde was timeless. She was a time machine.
With an unprecedented cultural impact, having operated for 27 years, the Concorde remains the symbol of a collaboration between two European countries, the symbol of a visionary era, and the symbol of a technological feat which to this day remains unmatched.